Welcome to the Control Plane. My name is Allyson Klein. In this series, we are exploring the control plane for AI data centers and what AI is requiring for new approaches. And to look into this story for this episode, we've got Stefano Righi, Chief Security Architect at AMI with us. Welcome, Stefano. How are you doing?
Very good. Thank you for having me here, Alison.
And Alex Williams, founder and publisher of the Newsstack and formerly at Newsstack, now in an independent role. Welcome, Alex. How are you doing?
Allyson, I am so excited to be here talking about these subjects that are just so fascinating now. And so I really look forward to the conversation. Thank you so much for having me, and nice to meet you, Stefano.
Likewise.
You know, it's such an interesting confluence of expertise on this podcast. You know, Alex, you've been covering cloud stacks, orchestration, and management of infrastructure for such a long time. You and I met like over 10 years ago when you had just launched the Newsstack. And Stefano, AMI is such a leader in terms of delivering the foundational technology that makes this all happen. And so I'm so excited for today's discussion. Let's just kick off with introductions. Alex, do you want to just give a little bit of a broader introduction of yourself and your experience in tech?
Yeah, thank you. Well, I recently retired from the Newsstack after starting it in 2014. The organization is now part of Insight Media Group, which is part of Insight Venture Partners. And we really started by looking at what is going to make scale possible. And it became apparent that containers really helped tell that story. And the community at the time just started to boom. Mm-hmm. And it really ushered in this whole world of cloud native technologies. By the time that I left the Newsstack, the Kubernetes cloud native world had matured considerably, but there were rumblings about what was to come. And data now was no longer thought of as necessarily a second tier citizen, which it had been for many, many years, relegated to the VM, for instance, you know, with in the stateful environments. So now that I'm kind of back and looking at the world, you know, from a new perspective, this conversation is fascinating because you can see the parallels and you can also see what is been behind the walls is something no one really noticed. Mm-hmm. And now that the walls are opening up, this whole wiring, this whole infrastructure of the house itself, so to speak, is needing a lot of work. And so this conversation to me is right on in discussing those topics.
You know, one of the key attributes of what is a challenge is privacy and security of that data. So I'm really glad that Stefano is on from AMI. Stefano, do you want to just do the same? Quickly introduce yourself. Give us some perspective on AMI's viewpoint of this key challenge that's facing the industry around control of AI data centers. And if you want to give us a sense of what it's like to be Chief Security Architect at AMI.
Sure. Thank you, Alison. I celebrated last year 40 years in the firmware industry. And and this year is the 27 year that I am in AMI, enjoying it a lot. And I have navigated through the firmware ecosystem in various roles, spanning from boot firmware, manageability firmware, security firmware. I started in AMI all the security operation 15 years ago, initially just starting the PCert, and then later about 6-7 years ago, also security products. So my role here is to help ensure that the trust is built from the chip to cloud. Firmware is a key element of the silicon security, which is essential to extend the trust through the software stack and ultimately protect the cloud. I work with engineering teams, silicon vendor, hyperscalers, and industry standard bodies to define security architecture, drive secure development best practices, monitor and mitigating emerging threats. A typical day for me goes from reviewing platform security designs and assessing supply chain risk. And all of this is happening through the collaboration on various industry initiatives, such as the Open Root of Trust technology and data center security framework. So
Nice. Now, Alex, I just want to go back to your intro for a second. You and I have known each other, I think, since 2014 when you started covering cloud stacks and I was working on cloud architectures at Intel. And since then, our parallel paths have been, you focusing on orchestration and control of infrastructure and me focusing on the infrastructure itself. So it's nice that this podcast is coming together to give us an opportunity to talk about the confluence of those spaces. Obviously, things have changed. AI infrastructure has evolved across compute, network, orchestration, software. As you look at that, which layer of infrastructure to orchestration do you see as getting the least amount of scrutiny right now in terms of the core capabilities that are required to deliver what folks are looking for from AI data centers, and also from a perspective of the risk it carries?
Yeah. When I went to KubeCon in Atlanta, Stefano's hometown, and I went to the AI track because I wanted to hear what they were talking about. And I listened to a conversation with a senior engineer from Uber. And they were going to multi-cloud. And they were starting to think through GPUs and how they were going to architect their new multi-cloud environment. And they were having all kinds of issues because what happened when we were going through those earlier years, 2014 to 2026, so to speak, we just assumed that everything was fungible, that you could just run anything anywhere. It was like everyone talked about commodities, right? Everyone talked about, this whole analogy emerged like cattle versus pets, right? And it was like, you don't have to worry about the network necessarily, it's, we don't have to, everything runs just beautifully, right? But that was like, because data wasn't really running through those architectures whatsoever. It might be on a VM, but most of it was just stateless, and so that really was interesting to hear what they were saying at Uber, because what they were experiencing was tremendous fracturing, where they had to configure every GPU from every different vendor, and that became a nightmare for them, and it still is. So we just came to assume over the years that Linux would really take us to, these new dimensions. But now we don't have that level of capability for the hardware. We don't have a Linux of silicon, right? We are starting to see it with projects like Caliptra, which I think we are going to talk about. We're starting to see it with some of the work that's been done within the CNCF but for the most part, the issue about what you can really trust is the big issue. And I think people are starting to get their heads around it, but it's still very, very new to people, because you just always assumed that the hardware could be trusted. It just was there. But now we are starting to understand that models can be poisoned, right? Well, how do they get poisoned? Then you got to start going into some of the deeper layers, and you start realizing there's a lot here.
Yeah. It's interesting. I was on the phone with a former Intel executive, and we were talking about the shift of power in the data center from, where we came from at Intel to the hyperscalers and neoclouds. And what you're talking about is so important, the heterogeneity of all of these accelerators and not having a single platform foundation of any kind really changes the landscape. And when you think about that, I think that from a silicon perspective, I think about that from a standpoint of the players and the capabilities. But what you're bringing to the table is so important, that the security assumptions that operators depend on are really relying on a common platform in which to engage, and that we do not have, I love the term, the Linux of silicon. How do you see that in terms of how that fragmentation is revealing some security assumptions we've made that are not holding?
Well, this is where Stefano can talk a lot about this, but I'll give my own 2 cents and just kind of the research that I've been doing. It basically talks about, how do you verify the chip, right? How do you actually do that when really the chip is is a black box, right? There's very little view into actually the architecture of the chip itself, right? So you got to think through like, well, what do I need to do here? And so that's where the attestation issue becomes, paramount, right? Where like you need to be able to see what is actually, when you do the verification, what does that report say? How does it differ though? But that's just part of the problem, because then you face all these networking issues, right? Because there's also lots of gaps there. And so now you're looking at like, can the chip be trusted? Right. But then also understanding, well, what's happening at the network level, right? What's happening with the network fabric? We'll find our way clearly. But what we're getting to is this interesting inflection point that we saw, I would say, in the 1990s when Linux emerged and they said, there's all these variations of Unix, right? How are we going to solve this problem? Well, they just created the kernel as we know it, the Linux kernel as we know it. Now, over time, the Linux kernel has been used in many ways to help kind of like, figure things out a little bit better. So we've seen Cilium, we've seen eBPF, we've seen Open Policy Agent, we've seen all these ways to kind of think through this. But now it's just getting to the point where it's like, can you actually scale these GPUs in the way you want? And also be certain that you can trust what you're actually scaling. Because if a model gets poisoned, you would assume, well, that, there's something wrong in the hallucination, but we don't assume that maybe it's the chip itself that is really the root of the problem. So it's the root of the trust is, it's like this chain of trust, right? Like this chain of trust, and like we've come to this divide between software and hardware. And it seems like that's almost like the chasm, so to speak, that we're trying to jump across right now.
Now, Stefano, I want to talk to you about what Alex is referring to in terms of chain of trust and attestation. But before we even get to that, you've been at AMI for a really long time. What is it like to be negotiating the landscape of firmware for such a heterogeneous environment? And I know that you guys call this out as one of the key challenges today for operators to navigate. How are you working with the silicon community to ensure consistency in the way that management, orchestration, security technology can engage all of this various silicon that's getting deployed?
Yep. Let me start with one word that is one of the main points that we highlight with our partner and customers, fragmentation. As you guys both mentioned, modern AI systems are assembled from components that are coming from many different vendors. And each one of these has its own silicon, its own firmware, its own update process, different security model. And this is a complexity that at the end can create gaps in terms of visibility and verification that also Alex was talking about. One time we were talking only about identity of the user that is using the infrastructure. Now we realize that not only user have an identity, but also machines things have an identity. So the only solution to this chasm is really to have a true root of trust. And a true root of trust must provide such cryptographic identity, must support a secure boot, must have measurement and attestation capabilities. And the only way to have this chain of trust rooted into a true root of trust is to have an hardware enforced foundation that can be independently verified. So really the solution is, in order to overcome all of this, is only transparency and openness. And you know how much AMI has invested into open.
Mm-hmm.
Open architecture is really the solution. So we may achieve this result with an open design that the ecosystem may review and really collectively trust. And really open is also the solution for the fragmentation that I was mentioning before, with all these players, each one going in a different direction. It becomes impossible to manage. Instead, with a solid open foundation that everybody can align to, this really provides a solution that can scale consistently across all these different platforms, all these different components that really are constituting the real complexity of the AI infrastructure.
You know, Alex, one thing that comes to mind is, I was at an event recently, and one of the neoclouds was talking to me, and he just said, I need a control plane that's looking across all this stuff, and I don't have it, and it's a complexity, to Stefano's point, that I just don't even have the time to manage. I'm busy building infrastructure to meet this AI moment. You know all of these cats. How aware are they of what's happening at the firmware and silicon telemetry level, do you think? Is this a recognized blind spot across the group, or is the industry still not really raising this as a question that needs to be answered by these deep tech companies that solve these types of challenges?
Well, on the front lines, we see all the conversation about compute. Right.
Mm-hmm.
We see all these conversations about the token economy. But if you look a little deeper, you start to see that what we established during the cloud native era really comes down to like establishing clear ways to verify pod to pod communication.
Mm-hmm.
And you had service meshes, and the sidecar served as like the control plane, right? And now, like, I think that what the people who are really starting to study this deeply, and I know that there are people out there who really are doing this, the people who are building, new ways to think about SRE, for instance, they're looking at this issue, I think, from this much deeper level, looking at the layer below orchestration. What we were able to do during the cloud native era was have technologies like sigstore, which allows you could verify it and the signature, and there was a sign off on the signature, you knew that there was some trust, right? It seems to me that what customers are thinking about right now is, how am I going to have that handoff, right? How am I going to make sure that there is this attention being put into the data that I'm getting from these reports, right? Right now, it's not really enforceable. And so I think they're struggling with that right now. They're trying to understand, like, what is it that I can really, again, what can I trust? And so I think they're not really understanding of it right now. If you look back, in the very beginning, we had, the container, madness, right? Everything's going to be stateless, right? Everything's going to work beautifully in this stateless environment. Well, there was no data really running through it. They said, this is not for state, right? And so they could, they could live with that. They did start to add like, CSI for storage, CNI for networking. So you started to have more, capabilities to, to verify technologies like, for instance, the memory, but when you got into, the later years, then you started to see, the emergence of like dynamic resource allocation. So you could start to verify things a little bit more, but still, it's only really kind of just, the surface level, work that's being done. So I think, if you went out and talk to these people, this is an issue that they are starting to understand a little bit more. The Open Compute Foundation has been doing, a lot of work. The Linux Foundation is, investing resources in understanding better the network fabric layer. So that will bridge the awareness. When I hear people like Kelsey Hightower talk about this these topics, he has a mistrust of AI.
Mm-hmm.
And I think the more skeptical technologists would, and I can't speak for Kelsey, but I do think that it comes down to, this realization that, we need to be thinking more about the trust at the hardware level.
Mm-hmm.
And that's going to open up the conversation. So we'll see not just a few visionaries talking about this, but much more so in a general conversation across the community.
Now, Stefano, I know that you've been involved in Caliptra. Alex gave us a preamble on Caliptra earlier, but it's an open source root of trust project on data center silicon, very involved in the OCP organization. What problem does it solve that proprietary approaches weren't solving in your mind? And does Caliptra address the foundational problem that we're talking about within fragmentation and hardware root of trust?
Thank you for asking about Caliptra, Allyson.
Mm-hmm.
What Caliptra addresses really is a trust problem, and it is not only a pure technology problem.
Mm-hmm.
If we look back what was happening before, the various root of trust implementation were all proprietary, and it was very difficult for the ecosystem participant to inspect and validate. Caliptra instead create a transparent and auditable foundation that any vendor, no matter if it is a manufacturer or an integrator, or also operators, can really trust collectively. For the AI infrastructure, where the fleets are, as we were saying before, more and more heterogeneous, an open and standardized root of trust help to establish a consistent attestation, a secure provisioning, and also a platform integrity that span across all these different and heterogeneous components that must be combined together into the infrastructure. So only a trusted root can really establish that verifiable chain of trust, which is the key, as we also mentioned it before. And in order to trust, you need to be able to verify. So we used to say that nobody can be the cop of himself, right? And in this very complex ecosystem, it is only the community that can be the real cop of the infrastructure. So what we are talking about here is Caliptra is the foundation of the composable security architecture that is becoming more and more relevant every single day, because when we compose together such different components, we need to have a common way in order to validate the security of each and every component, because it is only the trust to have authentic component that can allow the user of the infrastructure to really trust the entire infrastructure.
That's a really good point. And one of the words that you said kind of took me into a new space. Stefano, you said compose workloads. And I think that, we're sitting in a week where AMD highlighted their Helios platform and what they're doing from rack scale perspective. Obviously, others in the industry are working on similar designs. The quantum of compute is moving from the system to the rack or the pod. And, both of you have talked about the concept of pods. And the workload is constructing not just compute, but also access to data, as you've been talking about, Alex. And I'm going to take it a step further and say operators want to control not just compute, not just network and storage. They want to control their power and cooling as well in the same pane of glass. And we're hitting up against management, automated orchestration, and secure and trust of infrastructure that's going to be $1 trillion investment over the next few years. And I feel like we're kicking off a conversation just like we did, Alex, when Kubernetes was first born.
Yes.
Where this is going to be an acute focus of the industry over the next few years. How do you look at this, Alex, from your vantage point of having so much experience in the development of control for data center infrastructure? What does this moment feel like to you with that perspective, and why is firmware so important?
Well, firmware is about as close to a software control plane as we can get right now. Mm-hmm. And the expertise of the platform engineer is changing quite a bit. We really saw the emergence of the platform engineer, and they really emerged because DevOps was good, but it wasn't quite enough because of the cloud and the ability for companies to create their own very sophisticated environments for developers to launch applications very quickly. Mm-hmm. They became acutely aware, not just of the cloud environments, but the firmware as critical to the hardware software interface layer. And because that orchestrates the data movement, it helps manage the power, it configures interconnects. And this is where, I think over the past 2 years or 3 years, we've seen that move beyond traditional x86 or even ARM CPUs. So the firmware really dictates how these heterogeneous environments do actually work. Mm-hmm. And so that to me is very interesting because when these first control planes emerged in the software world, they became very critical because what we saw at that time was just the software supply chain had become so complicated. And so you had this mesh of APIs and there needed to be some way to reason with it. So you could actually be able to verify that the API was actually doing what it's supposed to be doing. And so now we're here in another time period where, where we have, a whole new set of issues, but there's some parallels too. If you look at, interconnect protocols, if you look at the hardware extraction layer, if you look at issues like memory management, telemetry and power, that goes on and on and on. And so what we're starting to see is this bridge, that divide again to understand kind of what is this connection between the work that we've been doing in these fungible environments for the past, 20, 30, even upwards of 40 years, and now how are we thinking about a data where data is the first class citizen and not a second class citizen at all. So that's kind of, I think, where a little bit where we are. We're now in the age of exotic pets, and I think what we're going to have to do is get to the age of exotic cattle. And that's going to require some exotic skills that I think are just emerging. And I believe, at least, that it'll help resolve some of the issues that you hear from people like Kelsey, who are saying, I don't trust AI. If you can start trusting it, that if you can have that trust all the way down to the hardware itself, where you don't have to verify endlessly, that's going to change how we think about AI technologies.
I love that. And Stefano, I feel like we could have this conversation for another 3 hours, and maybe there will be an invitation for a part 2 of this interview, but we are coming to the end. I'd love for you to give us your final thoughts on AMI's strategy to address turning exotic pets into exotic cattle that Alex has laid out?
Sure. Let's look at how the challenge of security has evolved through this evolution of the infrastructure. If we look back 15 years ago, the goal was simply to protect the individual platform, to protect from intrusion of malicious component into the firmware. Well, how this has evolved is that we need attestation in order to continue to monitor that there has not been any sort of intrusion into the entire infrastructure, not in any single component. So AMI bringing to the market a combined solution that put together data plane, control plane, security plane, allow to provide an holistic solution that is really bringing into a concrete path the exotic solution that I think Alex was mentioning about. So AMI is in a very particular place into the firmware ecosystem because it has navigated the control plane or better, it has invented the control plane, we can say. We have 40 years of boot firmware behind us, but the most important thing is that we look at all of this holistically together in order to provide that robust security infrastructure that is the foundation, as we were indicating before, for the chain of trust of the entire infrastructure, from chip to cloud.
I love it. I can't wait to follow this story further. Thanks, guys, for being with us today. One final question for the audience, because I know that they're going to want to engage before we get to a next episode. Where can they find you and connect to continue the conversation? Alex, do you want to go first?
You can just find me on LinkedIn. That's the best place to reach me these days. I'm Alex Williams on LinkedIn. If you look up Alex Williams in the news stack, you'll find me.
Awesome. And Stefano?
You can also look me in LinkedIn, Stefano Righi in LinkedIn. But you can also find me in many industry standard organizations and open source communities because I am participating in OCP, the MTF, UEFI, CHIPS Alliance. So if you are part of this ecosystem, you can surely find me there.
Well, thank you so much. This has been fabulous, guys. I can't wait to continue the conversation.
Allyson, great work you do there. Thank you so much.
Thank you, Allyson, for having us.